Hello, this is Scholar Stark doing some math today. In geometry, we're going to be looking at medians and altitudes. Okay, a median of a triangle is a segment drawn from any vertex to the opposite side. So let me show you one. So any vertex, so let's say I'm choosing this one, and you go to the opposite side and you split it in half into two congruent parts. Okay. And if you do these with all of them, so I'm going to start at this vertex now, and I'm going to go to the opposite side and split that in half. And then one more time. Split that in half. If you do that, all that, their intersection is called the centroid. And basically, the centroid, well, it has some properties. Okay, where is my... There it is. So let me label this really quick. A, B, C, D, E, F. And these are the properties. Oh, and the point in the middle is called P. So AP is equal to 2/3 of AE. And BP is 2/3 of BF. So let me color code these. So AP, we're looking at the blue line, is AE. So, and then BP, that's the black line. And then the red line, CP, is equal to 2/3 of PD. Or, sorry, CD, whole line. So CP is 2/3 of the whole line, whole red line. AP is 2/3 of the whole blue line, and BP is 2/3 of the whole black line there. And that means the other pieces would be 1/3. So PF would be 1/3 of the black line, GP would be 1/3 of the red line, and PE would be 1/3 of the blue line. Alright, 3 ways to calculate the center and position. If you know the whole median and the longer piece, then the longer piece is equal to 2/3 of the whole. If you know the whole median and the shorter piece, then the shorter piece is equal to 1/3 of the whole. And you know, let's just look at some examples for that. Quickly, let's go over altitudes. So altitude is very similar. You start at the vertex of any triangle, and here's the most common one. The height of the triangle is an altitude. But you can do it from any vertex, as long as it's perpendicular to that side. And this one's called the orthocenter when they all intersect. All right, let's do some actual examples. So GFH, in triangle GFH, point M is the centroid. Okay? And GM is 6. Okay? So to find ML, okay, they give us GM is 6. Find ML and GL. Okay, GM is equal to 2/3 of, so I'm looking at this line here, GL. We know what GM is, so that's the longer piece. So there's a longer piece and a shorter piece. The longer piece is equal to 2/3 of the whole, so GL. Okay. So I have 6 equals 2/3 GL. Okay. We're going to multiply by the reciprocal. So 3/2 times 6. So I flip the fraction and multiply it. So I'm going to get 18 divided by 2, which is 9. Okay, how do we find ML? ML is the shorter piece, and that is 1/3 of the whole. 1/3 of 9, and that would be 3. Alright, FK is 10. So they're saying that this whole line here, FK is 10. Find FM. So FM is the longer piece, so FM is 2/3 of 10. Why they use 10? Why couldn't they use an easier number? Okay. So 2/3 of 10 is 20 divided by 3. So 6, almost 7. 6 point something. And then MK is the shorter piece, and that's 1/3 of 10. So that's 10 over 3. All right, example 2. The vertices of JKL are these points. Plot the points in sketch JKL. Okay. So 1, 2, 4, 6, 3, 4, 1, 2, 3, 4, 5, 6, and 7, 4, 5, 6, 7 here. Connect the triangle. Use the midpoint formula to find the midpoint M of JL and sketch median KM. So this is JKL. They want JL, the midpoint of JL. Okay. So remember the midpoint formula is you add your x's together, so 1 and 7, and then divide by 2. And then you take your y values and add them together, 2 plus 4 divided by 2. And that'll give you 8 divided by 2, which is 4, and 6 divided by 2, which is 3. So 4 comma 3, 1, 2, 3, 4, 1, 2, 3. That's M. Okay. And then draw the median of KM. So you just connect the dots K and M. Find the coordinates of centroid P. Okay. So we know, so they're trying to find the center of the circle, which is somewhere there. We know that KP is equal to 2/3 of KM. And we know that KM is 3 if we just count there. 1, 2, 3. So KP is equal to 2/3 of 3, which is 2. So point P is 2 units away from the centroid. Or from, P is the centroid, from point K. So that would be 4 comma. So point K is 4 comma 6, so 2 units away downward is 4, 4. So it's around 4, 4 for that one. Or it is 4, 4. Alright, example 3. Triangle ABC is isosceles with base AC. BD is the altitude. Prove that BD is also the median of triangle ABC. So I'm actually going to skip the proofs for now and leave it to the class. I'm still debating whether or not... No, let's do these. Let's go ahead and do these. Statement, reason. Alright, so I'm going to say this is my first statement. And that's given. So I can move on to the second. Okay, so what does it mean for an isosceles? So triangle ABC is isosceles with base AC. Okay, that means AB is congruent to BC. Definition of isosceles triangle. If a triangle is isosceles, then 2 of the sides are the same, and they tell you that the base is AC. Okay. So to show that BD is a median, we need to show that AD is congruent to DC. So we need to show this is the same as that. So let's see how we can get there. Probably we're going to prove that the 2 triangles are the same. So they also give us that BD is the altitude of... That means angle BDA is congruent, angle BDA and angle BDC are right angles. Definition of the altitude. The altitude, start for vertex, goes to the other side, it's perpendicular to the other side. Alright, 4. We're just missing, so they both share BD, so BD is congruent to BD. That's the reflexive property. And we can show that the triangles are the same. Triangle BAD is congruent to triangle BCD, because we have wait a second. Oh, because we have HL. Yes, we have that side and the hypotenuse and a right angle. Now I can say that AD is congruent to DC because corresponding parts of congruent triangles are congruent. And now finally, BD is a median of triangle ABC. So if a segment starts at a vertex and goes to the midpoint, well, basically it's this definition up here, if I can find it. If a median of the triangle is a segment drawn from the vertex to the midpoint of the opposite side of the triangle, then the bisects that side. There we go. Basically, definitions, I'll just write definition of median of the median. Alright, checkpoint 2. Triangle ABCs is isosceles with base AC. BD, is this the same angle bisector? Okay, this is basically the same proof, except when you make it to the bottom, BD is the angle bisector. So you would show, when you prove that the two triangles are congruent, you would show that this angle ABD, is congruent to angle CBD, and that would be through CPCTC, congruent, corresponding parts of congruent triangles are congruent. And then once you show that, then you've shown it's an angle bisector. So same exact proof, just at the end. So starting at step 6, you would say angle ABD is congruent to angle CBD by CPCTC. And then 7, you would show that it's an angle bisector because it splits the angle in half. And that's that. Have a good day.